All right, so state the degree, leading term, leading coefficient, and the constant. Now the degree is going to be the highest exponent. So in this case, the degree, I'm just going to say d for degree. It's not d. You'd actually write out degree, but that's going to be 2 because that's the highest exponent. The leading term, that's going to be the term that has the degree in it. So that's this. So that's minus 3x squared. The leading coefficient is what's in front. So that's negative 3. And then the constant is just the number that doesn't have anything associated with it. And so that's going to be 4. So for number 2, the degree, the highest exponent is 17. The leading term, it's whatever the term is that has the degree in it. The leading coefficient is whatever's in front, which is radical 3. And then the constant is just the number with no x. Now, if there isn't a value, let's just say there is no number with no x in it, then their constant is 0. So we can see that one in this next one here, where it's like, okay, the degree, the total number of x's that I have. So I have 1, 2, 3, 4. Right, because it's squared, so you have to count it twice. So my degree is going to be 4. Now, to find the leading term, since everything's factored, if I were to write this out, this is x times x minus 3 times x minus 3 times x plus 1. All you have to do is multiply the leading terms of each one. So leading term, leading term, leading term, leading term. If you multiply the leading terms of each one, x, 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 and x, you're going to get x to the 4th power. Then the leading coefficient, so what's the value that's in front of that? That's 1. And then the constant, if I multiply the constants of all of these, well, this is x, so x times negative 3 times negative 3 times 1, that's going to be 9x. Well, there's an x next to it. So my constant is actually 0. So let's look at another one for that. So the degree, it's the number of x's. So 1, 2, 3, 4, 5. And then the leading term, I have to multiply the leading terms of every factor. So x squared times x times x times x, so that's x to the 5th. The leading coefficient is what's in front. And then the constant, well, x squared times negative 3 times 1 times negative 5, it's going to make it 0. For this one, my degree, that doesn't count for anything. So 1, 2, 3, right? That doesn't count for anything. My leading term, I got to multiply it though, because it is a leading term of all the factors. So this will be 4 times t squared times t. So that's going to be 4t to the 3rd. My leading coefficient, that's just going to be 4. And then for a constant, I have 4 times negative 2 times 1/2. So that's going to be negative 4. Now, continuing logs, remember to get rid of the log, you take the inverse base, but you can only do it when there's one log, at least on both sides. So the inverse base cancels out. So now I have to factor it, so bring it over. There's an x in common, and then that factors into x plus 1, x minus 1. So then you get x equals 0, negative 1, positive 1. But now we have to check for extraneous solutions. If I plugged in 0, I get log base 2 of 0. You can't have a 0 inside of a log. If I plug in negative 1, I get log base 2 of negative 1. You can't have a negative inside of a log. But if I plug in positive 1, it's going to work. Base 3, So 7 minus 2x equals 9. Negative 7. So now plugging it back in. If I plug back in negative 1, I get 7 minus 2, which is, or times negative 2. 7 minus 2 times negative 1. It's 2. 7 plus 2. So that's 9. Log base 3 of 2 is 2. 2 equals 2. So then I can confirm that's my answer. For number 8, remember we have to condense it first, because there's no operation that distributes amongst logs. So you're going to get x minus 4 and then times x plus 4. Right? It doesn't go on the bottom. I thought maybe there would be something on the bottom, but there isn't. So base 3 to both sides. So now this is quadratic because I have two x's, but it has to equal 0. So for me to make it equal to 0, I have to multiply everything out. So x squared plus 4x minus 4x minus 16. So that's going to cancel out. So subtract the 9. So then that's going to be x plus 5, x minus 5. So x equals 5 and negative 5. So now testing them. If I plug in positive 5, 5 minus 4 is 1. 5 plus 4 is 9. Okay, it's positive, it works. If I plug in negative 5 minus 4 is negative 9. You can't have a negative inside of a log, so you have to reject it. And so my answer is going to be that x equals 3. So now for this one, my parent graph, remember, it looks like that. So the horizontal shift is 3. So your domain, don't know why I did that. It's not as curvy. It's hard to write on the screen. So my domain will be from positive 3 to infinity. My range is going to be from 0 to infinity. Now this is the rational, right? What happened last time? Right, and it moves around that. So, but I have a vertical shift of 5. So that center, 1, 2, 3, 4, 5. So here's my horizontal shift. Here's my new vertical and horizontal asymptote. And then so if you want to plug points to make it a little more accurate, and so my domain is going to be negative infinity to 0, 0 to infinity, and my range is going to be from negative infinity to 5 union 5 to infinity. So there's my graph there, and they're both negative infinity to positive infinity.